Okay, last up for section 7.2 is going to be topic 5, which is complementary angles and cofunctions. Okay, so one definition I've given to you, the other one I kind of thought you might know, but I'll remind you of it just in case. So, any two angles whose sum is 90 degrees are called complementary angles. Okay, so complementary angles, any two angles, these have to be pairs of angles that have a sum of 90 degrees would be considered complementary. Now, the other definition that I didn't put in here that I kind of wish I had, I'll just put to the side of this picture. When you're dealing with the angles of a triangle, so we know there are three angles in a triangle, they have to have a sum of 180 degrees. So the three angles in a triangle have a sum, that just means add, have a sum of 180 degrees. And that does matter in just a minute. Okay, so we have a very standard looking right triangle. Okay, and notice we have the right angle, which is right here. So this is our 90-degree angle. You should definitely know that by now. And then we have angles B and angles A. Okay, well, over here on the right-hand side of this box, it says in the triangle to the left, angles A and B are complementary. How do we know this to be true? So we know complementary angles are any two angles that have a sum of 90 degrees. Well, how do we know that A and B are complementary? Well, kind of easy. We know that the three angles of a triangle are 180 degrees. Okay, we know that. I just told you that. Okay, we know that when you're dealing with a right triangle, we have one 90-degree angle. So if we take 180 degrees and subtract the 90 that we've already used, that leaves 90 degrees. So A and B basically split the remaining 90 degrees, making them complementary angles. Okay. And there are two types of triangles that are super, super important that we just love to work with in trigonometry called a 30, 60, 90 triangle and a 45, 45, 90 triangle. That all kind of plays off of this right here, but we'll deal with those in another section. Okay, so example 7 says use the triangle to fill in the table. What do you notice about the values in the table? Okay, so we have the exact same triangle from above. Okay, we have a right triangle, we have the 90-degree angle, we have angles A and B, we have sides A, B, and C. Okay, nothing has changed. We're asked to fill in this table. So this table wants sine of A, cosine of A, sine of B, cosine of B. So just really quickly, in case you're still struggling, remember SOHCAHTOA. That tells me that the relationship between theta or whatever the angle is and the lengths of the sides would be opposite over hypotenuse. And for cosine, it would be adjacent over hypotenuse. Okay, so let's look at sine of A. So sine of A, we're dealing with this red circled angle. So when we're dealing with sine of A, the opposite side is side A, so lowercase a. And we know that the hypotenuse is C. So we would say that sine of A equals little a. Oh, it's doing that again. I don't know why it does that. So sine of big A is going to equal little a over C. Okay. Now, if we're dealing with cosine of big A, then the side adjacent to big A is little b. So then knowing that cosine is adjacent over hypotenuse, we would have little b over c. That is going to drive me bonkers. I don't know why it's doing that. Okay. Now let's flip all of this and look at angle B. So capital B. So let me erase this so we don't confuse ourselves. And let's do this one in blue. Okay. Now we have angle B. So when we're looking at the side opposite to angle B, we have lowercase b. And then angle or the side adjacent to angle B is lowercase a. Okay. So let's find sine and cosine of angle B. Okay. Well, if we're looking at sine of B, it's opposite over hypotenuse. So that would be B over C. And then if we're looking at cosine of angle B, that would be adjacent over hypotenuse. That would be A over C. Okay. So what do we notice here? The directions say, what do you notice about the values in the table? Well, what I notice is that sine of A equals cosine of B. Notice right here, those two are equal. Okay, so if I have sine of A, the ratio is equal to cosine of B. Well, that's really neat, right? And then if I look at cosine of A and sine of B, those ratios are equal. Okay, so then we have sine of B equals cosine of A. So what does that tell us? Well, we already know that A and B are complementary. So they're complementary angles. You could also have people say they're complements of each other, okay? And so what we're seeing here is that we have this really cool relationship where sine of A is equal to cosine of B, sine of B is equal to cosine of A. What does that all mean? So we have something called the complementary angles theorem. The complementary angles theorem says cofunctions of complementary angles are equal. Well, that's great, but what in the tarnation is a cofunction? I'm here to tell you. So cofunctions are trigonometric functions whose values are equal when performed on complementary angles. Okay, so we know that sine of B is equal to cosine of A. A and B are complementary angles. So what we have found is that sine and cosine are cofunctions. Okay, and it should make sense. We see the word sine and then we see cosine. Okay, and then notice we have tangent and cotangent. And then we have secant and cosecant. These are cofunctions, okay? So sine and cosine are cofunctions. Tangent and cotangent are cofunctions. Secant and cosecant are cofunctions. So if we were to take secant of some angle and then cosecant of the complement of that angle, we would get the same ratio, okay? So let's practice this. We're going to put this into practice. So example 8 says, use the complementary angle theorem to find the equivalent statement. So we have sine of 35 degrees. Well, what in the world is sine of 35 degrees? We need to find an equivalent statement to this. Okay, so what we know, sine and cosine are cofunctions. So we know sine and cosine are cofunctions. We also know that we have this idea of complementary angles, which is very, very important when it comes to cofunctions. So if I have an angle that is 35 degrees, what's the complement to that? Well, I would take 90 and subtract 35. Well, 90 minus 35 is 55. So we know that 35 degrees and 55 degrees are complementary angles. I'm running out of room. So if I wanted a statement that is exactly equivalent to sine of 35 degrees, then I need to use the idea of cofunctions and complementary angles. So this would equal cosine of 90 minus 35 degrees. So that would equal cosine of 55 degrees. So these two things right here are equal. Okay? So let's do the same thing with tangent of pi over 3 and secant of pi over 12. But before we do that, we're dealing with radians here. We've got the pi in there, so you know you're dealing with radians. Let's remind ourselves of something. We need 90 degrees because we know complementary angles have to have a sum of 90 degrees. We need to remind ourselves of what 90 degrees is in terms of radians. Okay, so let's look at 90 degrees in terms of radians. So we have 90 degrees, and hopefully you remember that there's a relationship between radians and degrees, and it is that there are 180 degrees in pi radians. Okay, so we want to multiply 90 degrees by some unit fraction that relates degrees and radians, and we want the degrees to cancel, and we want the radians to be in our numerator. So I'm going to say that this is pi radians over 180 degrees. And as weird as it looks, this is really just equal to 1. So a lot of people say it's a well-chosen 1, okay? So we're not changing the value of our 90 degrees, we're just converting it to radians. So quite literally, the little unit degrees cancel. Okay, I know that 90 divides into itself once and into 180 degrees twice. I'm going to erase this little one so we don't confuse ourselves. Okay, so when I simplify this, I get 1 times pi radians over 1 times 2. So that tells me that 90 degrees is equivalent to pi over 2 radians, okay? And we're going to use that here because we need this idea of complementary angles. Complementary angles have a sum of 90 degrees. In the world of radians, complementary angles would have a sum of pi over 2, okay? So we need an equivalent statement to tangent of pi over 3. Well, tangent and cotangent are cofunctions. So we need to convert this into something with cotangent. Okay, so this is going to equal cotangent of 90 degrees, which is really pi over 2 minus pi over 3. So let's see what that's going to look like. We need to have a basic understanding of fractions, okay? So if you really, really struggle with fractions, you need to work and get some practice with fractions, okay? So when you're dealing with fractions, we need to have a common denominator, okay? So we need an LCD, and in this case, the LCD is 6. Okay, so what would I multiply these denominators by to get 6? Well, 2, I'd have to multiply by 3, so I want to multiply top and bottom by 3, which again is really just a well-chosen 1. I would need to multiply 3 by 2, so I need to multiply top and bottom by 2 here. And what that gives me is cotan of 3 pi over 6 minus 2 pi over 6. We'll kind of treat the pi just like a variable. It's not, but treat it like one. What is 3 pi minus 2 pi? Well, it would just be 1 pi. So we would get that this is cotangent of 3 pi minus 2 pi over 6, which is just pi over 6. So these two things are equal. Okay? Now let's do the same thing, but this time we have secant of pi over 12. Well, secant and cosecant are cofunctions. Okay? So we want to rewrite this as something with cosecant. Okay, but what? Well, secant of pi over 12 is equal to cosecant of 90 degrees, which we know is pi over 2, minus pi over 12. So again, just like in the previous example, we need an LCD. So the LCD here is 12. What would I multiply 2 by to get 12? 6. So I'm going to multiply top and bottom by 6 here. I don't need to mess with pi over 12. So this is cosecant of 6 pi over 12 minus pi over 12. So pi is not a variable by any stretch of the imagination, but treat it like one. What is 6 pi minus 1 pi? Well, that would be 5 pi. So we just get 5 pi over 12, and these things have to be equal. Okay, so that is the, if we scroll up just a smidgen, that's the complementary angle theorem. Cofunctions of complementary angles are equal. Okay? Is this the last one? Okay, so last up it says, example 9, without using a calculator, find the exact value of each expression. Now, we've just learned about cofunctions, so let's use that complementary angle cofunction relationship, okay? So remember, cofunctions are equal when they're applied to complementary angles. Okay, so for part A, we have tangent and cotangent. These are cofunctions, okay? So we're happy about that. These are cofunctions. Also, what do you notice about 75 plus 15? Well, hopefully at home you're not scratching your head and you're like, well, 75 plus 15 is just 90. So this is 90 degrees. So these are complementary. Okay, so what I want to do is I want to get a relationship or a ratio here that has the same function. So either both tangent or both cotangent. Okay, so let's say we want to convert everything to tangent. Okay, so that tells, whoops, that tells me that I want my numerator to stay tangent of 75 degrees. Well, I need to convert cotangent into something using tangent. So I know the relationship between cotangent and tangent with complementary angles is that cotangent of 15 equals tangent of 90 minus 15. So my numerator is still tangent of 75 degrees. My denominator is tangent of 90 minus 15. Well, what is 90 minus 15? It's 75 degrees. Well, tangent of 75 degrees divided by tangent of 75 degrees, they're the same thing. You're just taking one ratio and dividing it by exactly the same ratio. So we get 1, which I think is super fun. Okay, last up we have cosine of 38 degrees and sine of 52 degrees, and we want to subtract the two, okay? Well, what we notice first is that we have cofunctions, and then two, let's think about 38 and 52. So what is 38 plus 52? Well, 38 plus 52 conveniently happens to be 90 degrees. So these are complementary angles. So we want to rewrite this statement where we have both of these expressions as sine or both as cosine. Doesn't really matter which. Let's say we want to convert everything to cosine. Okay, so that tells me that cosine of 38 degrees is just going to stay cosine of 38 degrees. But then sine of 52 degrees, I want to rewrite that as cosine. And we know the relationship is cosine and sine are equal if they're applied to complementary angles. So I can rewrite sine as cosine. So sine of 52 degrees is equal to cosine of 90 minus 52 degrees. So I get my cosine of 38 degrees. And then I have cosine of 90 minus 52. Well, 90 minus 52 happens to be 38 degrees. Well, cosine of 38 minus cosine of 38, I have one ratio minus the exact same ratio. This is equal to 0. Okay, so keep these little tricks in mind. We've learned lots and lots and lots of little things, and you don't necessarily have to memorize everything, but you do need to understand these relationships and how they work. So as much of this as you can commit to memory, the better off you're going to be. Okay, so I'd say work hard on memorizing and understanding now to make the rest of this course easy as you go along, or easier. All right. It's been a long night, so I'm going to call it quits.